Ladies and gentlemen, today we are going to be looking at solving equations one step, lesson 3.3. So on the web page again, Math 7. But before we do that, just want to remind you that let's see, will it actually load up? There we go again. You have your answers for 3.3, since those are evens, posted right there. Beautiful. All right, so going to the textbook, chapter 3. I'm going to have to scroll down a little bit. Again, 3.3, addition or subtraction. And then next week, we're going to do a multiplication and division, and most likely move into the two-step, because again, those are super, super important lessons there. So let's see. Got the activity, we'll skip that. Let's get to the actual quick notes in the textbook, then we'll do some problems together. All right, so in Math 8, we actually spent time last week practicing solving equations. This week, we're continuing that, throwing in some geometry as well. But again, solving equations is super important. Refreshing our memory with one step, we've got our addition property, subtraction property right there. The whole idea is to try and keep it balanced again. So in other words, if I add a 5 to the left side of the equation, then I have to add a 5 to the right side of the equation. Or if it's subtraction, subtract 2 on the left side of the equation, subtract 2 on the right side. And that's why throughout the year, I always said subtract 2 on both sides, because again, trying to keep it balanced, as it says, it produces an equivalent equation. So right here, we look at our original problem. It says x subtract 5. So again, remember, we want to do the inverse operation, which means if it says subtract 5, we're going to go ahead and add 5. Now remember, it's not the opposite. It's trying to undo the subtraction by using addition. And then we're going to practice our positive and negative numbers, addition, subtraction, just like we've already been practicing from week 1 there. Even if it's a fraction skills, so it says plus 3/2, so that's why we will subtract 3/2 on both sides. And again, we will practice our fraction skills. Remember, in order to add or subtract, they have to have the same denominator. And if they're not, then we've got to fix that. All right, so we've got some on your own questions there. We'll get to those in just a moment. Remember, the word problems can also be very similar. One of the things that we tried to remind you is certain terms mean either addition or subtraction, and there was one tricky one, and that was specifically less than. Those are the ones that students usually have it confused. So if it says 10 less than x, it's not 10 subtract x, it's really the other way, x subtract 10. So again, that was the main tricky one that we had for our word problems ideas. All right, and then you got some exercises. Like I said previously, the evens, so we're actually going to do a few additional odds. So let's jump into the on your own and then some of the odd problems as well. All right, lesson 3.3. Solve the equation, check your solutions. So we're just going to go ahead and jump right into that real quick. So for number 1, zooming in. All I'm going to do is recognize, okay, it's very similar to the notes on the web page. Add 5 both sides. Because again, that's the inverse operation. So I line up the equal signs. The P is equal to, now remember, a -5 plus 5 we already know is 0, so please don't write that, because our concern is right here, -2 plus 5. So remember, they are different, so I will subtract and get a 3. Then I take the sign from the greatest absolute value, which is from the +5, so therefore it's a +3. I'm done there. The checking is mainly concerned for when we get to our two-step, multi-step, variables on both sides, and above and beyond in 8th grade, 9th grade, and so on. But again, the check is real quick. It's just a 3 subtract a 5, and we hope to get a -2. Now this checking idea is also very helpful in 8th grade. When we're trying to see if we have our answer for x and y correctly, this is a way to check. 3 subtract 5, remember they are different, so we take the subtracted answer, which is a 2, take the negative sign from the -5, or if you remember, it's really add -5. That's why -2 is equal to -2. So that does check out. All right, on problem number 2, it says plus 13.2, so inverse operation is to subtract 13.2. So a W, line up the equal signs. And then for this one, I am going to subtract, but I can't subtract as it is presented to me right there. 4 subtract 2, that's nice, but you can't do 0 subtract 3. Because remember, in elementary school, we always asked you, so I'll erase this in a moment, we always asked you to make sure that the bigger number, because again, we're not worried about the negative sign right now, is at the top. Because the rule is to take the difference, which I'm going to do right now. 12 subtract 4 is 8. Line up my decimals, 2 and 0. So we've got 2.8, which is the difference, and then I take the sign from the greatest absolute value. So that's from that negative 13.2, so that's negative 2.8. But again, our subtraction has to be structured elementary, like off to the side. To check it, it would just be here, negative 2.8 plus 13.2, and we hope to get 10.4. Now, over here, again, they are different, so I'm going to go ahead and subtract it. So that's 13.2, subtract 2.8. Can't subtract, so I borrow. 4, 0, 1. So 10.4 with the positive sign that's hidden is equal to 10.4. Looking good. All right. Fraction problem now. Now, if you notice, the fractions do have the same denominator, so that means I am able to move it and combine it right away. I don't know why the 5s never work. Line up my equal signs. X is equal to denominator of 6, because again, they have to have the same denominator to add or subtract. They are different, so negative 1 and positive 5, so I'm going to subtract, take the difference, gives me a positive 4, because the positive 5 has the greatest absolute value. But remember, if you leave it like this, it's unacceptable. We got to practice our reducing, simplifying. If most of you could probably do it in your head by now, but if you need to, show that divide by 2, which is how we get our 2/3. In 8th grade, we do prefer fractions. 7th grade, we do practice our decimal form, because maybe it wants to have a decimal form. 2/3, or maybe you remember it, 0.6 repeating, because it's 0.66666, all of that stuff. We're not worried about the rounding, so we put the repeating bar there. All right, if you wanted to check it, remember, to check it, you really have to use the same denominator form, which would be the 4/6. But your final answer was 2/3. So checking it would be 4/6, subtract 5/6, and we hope to get negative 1/6. So again, we remember we can subtract. We hope to get negative 1/6. So take the difference. The difference between a 4 and a 5 is a 1. We take the negative sign from the 5. Boom, it looks good there. All right. So we practice some skills there for on your own. Your assignment is going to be very similar to that. So we have the odds here. So I'm just going to pick a few maybe. Ooh, let's look at 17 since we were just talking about that fraction. Let me write it a little bit bigger. It says Q, so let's actually change it to an X. X is just a little bit easier to read. So X plus 5/9 is equal to 1/6. So you can do it here or in a moment, but I'm not able to actually subtract because different denominators. So if I'd like to, I can go ahead and put it over here as equivalent fractions with a new denominator. LCD between 6 and 9 would have to be an 18. So let's go ahead and change those. So 6 multiplied by 3 gives me my 18. So 1 times 3 gives me a 3. 9 times 2 gives me 18, so negative 5. Remember, that's negative 5 times 2 gives me negative 10. Now, since they have the same denominator, I am able to figure it out. Take the difference again. Difference of a 3 and a 10 is a 7. Take the negative sign from the 10. It has a greater absolute value. I cannot reduce that, so I am done with 17. Let's see. Oh, on number 11, what I tell a lot of my 8th graders is I don't like it in this form here. So I just go ahead and put the half on the other side and lightly cross it off. So number 7, I would put the negative 14 on the other side and lightly cross it off. In 8th grade, we want to focus on having your variable on the left side for your answer, and that ties into our inequalities as well as other stuff that you'll see more in high school. So let's actually just do one more, number 19. W, but I'm going to change it to an X. I like X. I'm actually going to suggest that we change this to an improper fraction really quick. My daughter's 5th grade, learning how to do this, not the solving equations part, but just changing it to improper fractions. You should have this experience as well. So 8 times 3, add 3. So 8 times 3 is 24, add 3 is 27 over 8. I usually like working this way. 6 times 1 is 6, plus 5 is 11. 11 over 6. All right, so it looks somewhat similar to the previous one. Let's go ahead and subtract 27 over 8, both sides. So x is going to be equal to something. Let's zoom in for our vision challenged friends. All right, let's get some equivalent fractions here. We need an LCD. Let me give you a moment to think about it. Please don't just do 6 times 8, because that is a common denominator, but it's not the lowest or the least common denominator. So what can you do instead of 48? Did you say 24? I think that'd be a little bit better. Still maybe not great, but better. So let's see. 6 times 4 is 24, so 11 times 4 is 44. 8 times 3 is 24. Negative 27 times 3, so that's going to be negative. So I know 20 times 3 is 60, and 7 times 3 is 21, so 60 and 21 gives me 81. Or you can go off to the side and do 27 times 3. There we go, negative 81. Okay, so I can take the difference, and I can already predict it's going to be negative because 81, the negative 81 has the greater absolute value. So there we go. Now, if you can't subtract it in your head, then you're just going to do it right near the work, probably the margin type of idea, and do 81 subtract 44. So let's borrow, regroup, whatever your teacher taught you. So that's 7, 11. 11 subtract 4 is 7. 7 subtract 4 is 3, 37. So that is our improper fraction. Cannot reduce it because 37 is not going to be nice and neat there. One thing we want to continually remind our students, though, is the mixed number answer. So I'm going to erase this just for a little bit of room. Not that much. So it is going to be a negative still, and I like to think about it with pies, very tiny slices, 37 slices, 24 slices is one whole pie, so that means I've got one whole pie and something left over. 24 times 1 is 24, but I want a 37, so it's going to be a 13 there. Looks pretty good. Any questions or concerns, send us some emails. We can try and answer you, or maybe answer for the whole class. Keep being awesome. And we miss you guys.